Hello, and welcome to this video on hypothesis testing continued. In this case, we're going to be using t-scores for our p-values because we're going to have sample standard deviations instead of population standard deviations. So you should be familiar with when we have that scenario, we've been going to the t-score chart. So testing is pretty much considered the same as you'll see in this example. It says a certain breed of frog is known to jump an average of 15 inches. Amy catches 9 of the frogs in her backyard and finds the sample to jump an average of 13 inches with a standard deviation of 1.3 inches. So the way that's worded is understood that the standard deviation here comes from the sample. Amy wants to test to see if the frogs in her area jump less than 15 inches using a level of significance of 0.05. So here we state the null hypothesis where the population mean is known to be 15 inches. And her alternate is she believes that population mean is now less than 15, which would be a left tail test. We'll look at that again in a moment because it's a little bit different here. But the level of significance is 0.05. The sample size was 9. Remember that when we have a sample size and we use the t-score chart, we have that degrees of freedom, which is 1 less than the sample size, so that'll be 8. S is a sample standard deviation, which is 1.3, and the sample mean from what Amy collected is 13. So we'll use all that information and we'll jump to calculating a t-value, which is used when once again we have a sample standard deviation, and this is important because also the sample size will matter when we test. Okay, the larger the sample, the more accurate we expect it to be. But our sample size was 9. So calculating everything here, the t-score, or from the formula, we get a negative 4.61538. You notice that I made that positive. As we'll see in a moment, you may remember that the t-score only gave us positive numbers when we went to the chart. But anytime you get a negative number out of the t-score here, and we're doing a hypothesis test, go ahead and make it positive. Okay, and we're going to use that value. So we're going to use positive 4.61538. Okay, so just drop the sign. And here's the t-score chart, and here's why. You see up here a one tail and a two tail. So this takes place whether it is to the left or to the right. So it doesn't worry about that. It just takes the same value whether it's below or above as long as it's one tail. So a negative 4.6 ends up in the same place as a positive 4.6 if you're on the other side. So treat both of those the same as a one-tailed test. And in the past when we used this chart, we were concerned with this C for a confidence interval. We're not concerned with that now, so ignore this. Okay, just look at the one tail or the two tail and the degrees of freedom. So remember our 4.61 and our degrees of freedom of 8. So we look at our degrees of freedom 8. We come over, we don't have a 4.61, but it would be between these two numbers. So the value we get for t is usually not going to be in the chart. That would be very rare, but it'll be between two numbers. So the p-value we get will be between two numbers. Our p-value will be between 0.0005 and 0.005. So this is what? 0.05%, and this is 0.5%. So our t is between these two numbers, and because it's a one-tailed test, our p is between these two numbers. So we don't know p exactly, but if we know it's in that range, and we compare it to the level of significance we had, we know that anything between here is less than 0.05. So p is definitely less than alpha here. So we're going to reject the null hypothesis of 15. So we believe that the average is now less than 15. So big change here with the sample standard deviation using the t chart to get a p-value. We get a range for p's, but those p's would often fall outside of the level of significance that we have. So let's do a second example with a two-tailed test. Here, average battery life is known to be 300 hours. We test 8 batteries that have an average life of 250 hours, and that sample has a standard deviation of 50 hours. And the question is, does the sample suggest that the life of the batteries is different from 300 hours using a level of significance of 0.01 or 1%? So our outside threshold, our outlier range is very small there with a 0.01. But here are all the things. Because we said different from 300, that's a two-tailed test, not equal to. And because our sample size was 8, our degrees of freedom is 7, two-tailed. So we go to our chart. Well, first of all, we got to calculate the t-value. It comes out to be negative, but we can make it positive. And I have been keeping a lot of digits here just because I know it needs to fall between two numbers. So it should never really fall on any number. But here we're using the two-tailed test, and our degrees of freedom was 7. So our 2.8 is between the 2.3 and the 2.9, which means our p-value is between 2% and 5%, 0.02 and 0.05. So because the p-values here, the smallest p-value we have is 0.02, and that's bigger than 0.01. So if p is bigger than alpha, that means we fail to reject.